Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in the subject short range wireless communication. We're going to see fundamentals of RoF technology. So in this video we will see the fundamentals of RoF technology, what are the benefits of RoF technology, and what is the difference between RoF and UROF technology. That is what we're going to see, right? And to start with the fundamentals of RoF technology, first you got to understand what is RoF technology, right? This is a very important technology where it is the main reason for the emerging technology, which is UROF technology, which we have seen already in previous video, right? So RoF is nothing but radio over fiber. Right, in order to achieve broadband wireless access network, right, this is very effective. That is radio over fiber, which means we're going to transmit radio waves over the optical fiber so that we can able to extend the radio wave, that is the range of the radio waves, and also we can able to achieve the benefits of the optical communication, that is faster transmission, channel capacity, right, low noise, all those advantages of optical fiber can be achieved, right? So you can see here that this is the normal working where we'll use the RF signal. That RF signal is converted to an optical signal, and that optical signal is transmitted, and once again at the receiving side it has to be converted back to the RF signal and it will be received, right? So that the transmission will be happening with the optical system, that is with the optical fiber, whereas the signal transmission and reception is the RF signal, right? So this is the basic about RoF technology, and this basic RoF technology is the very fundamental concept for UROF technology, which also work in the same concept. What is UROF technology? UROF technology is UWB, radio over optical fiber. We are going to extend the UWB RF wave by using RoF technology. That is why it is called as UROF, right? So that the transmitter will be UWB transmitter and the receiver will be UWB receiver, but the transmission is going to happen optically. That is same like RoF, right? And when we do RF transmission, that is RF signal to optical transmission, then we can able to achieve lot of advantages. That is, there will be a minimum loss, right? Data transmission will be very faster, right? And you can able to have wider bandwidth, right? And but for that we need to convert the RF signal to an optical signal. That is the very important thing. The very important thing in this RF is the conversion of the signal, the RF signal to optical signal and optical signal to RF signal. That is, the RF signal will be superimposed with the light wave and then it is transmitted through the optical fiber, and similarly again it will be converted to RF and it will be received by the receiver, right? And lot of efforts, this is mainly preferred for broadband wireless access network in remote areas. We can able to achieve broadband wireless access, and a lot of efforts has been taken to reduce the cost of central station. And this is the network, that is the architecture of RoF system, where you can have a central station, a single central station, and you'll have a number of base stations. You have number of base stations, and these base stations will be the access point for the subscribers, right? This will be acting as a access points, and all the operations like filtering, modulation, everything will be done by central station, not by the base station. All the operations like transmission, controlling, filtration, modulation, everything will be done by this particular control station. And this base station, what is the working of this base station? The main working of base station is to convert the wireless signal here, the wireless signal to optical signal and optical signal to wireless signal. That is the main operation of this base station. You can see electrical to optical and optical to electrical conversion, right? And it will transmit and receive. right? And all these base stations are interconnected using optical fibers, right? And this system is very effective for broadband wireless access networks, right? So whatever I said, that is, this is mainly preferred to reduce the cost of base stations, right, and remove the complexity of the central station, and mainly preferred for broadband wireless access networks. And as I said, CS performs all the operations, switching, routing, and operation administration, maintenance, everything. The optical network interconnects the number of antennas and as well as the base stations, right? And base station will not perform any processing function. As I said, it will convert only the optical signal to wireless and wireless to optical signal, and it will act as a service access point for several subscriber stations. And the proposed architecture assumes centralized medium access control, right? And CS is responsible for offering reservation based collision free medium access network, right? So all the operations, switching, routing, and maintenance is done by the central station, whereas the conversion is obtained by, that is, optical to wireless and wireless to optical conversion is achieved by base station. And I've already explained what is UROF. UROF works in the same concept. It works in the same concept, that is radio over fiber. The only thing is this radio signal will be a UWB radio signal. That's all, right? So what we can do is we can able to extend the UWB range. That is, we have lot of advantages of UWB technology. That is, it has penetration capability, it has precise location capability, right? It is a very powerful short range communication technology, but the range of the thing is less than 10 meters, right? So we can able to extend this particular range, and we can able to achieve all the benefits of UWB technology by using this UROF concept, which works on the basics of RoF, right? And you have to understand the difference between UROF and as well as conventional RoF technology. As I said, the main goal of UROF is to extend the short range communication to the order of 1 to 3 orders of magnitude, right? And UROF follows separation of low cost base stations from CS, same like the RoF, right? So the working is completely same like RoF, but the main difference here is UROF is mainly planned for PAN network, that is personal area network, whereas the conventional RoF is based for cellular systems, right? You can see the addresses the challenge of range of extended for low cost WPANs, but it is used for wireless access systems. If you WPAN is nothing but wireless personal area network, right? And it targets mainly for PAN market, whereas here it targets for cellular system, and it is characterized by very low cost and low power access points. Here the RF signal bandwidth is only 10 megahertz, and its average power is several 100 milliwatt, right? The optical is used to carry extremely wide RF signals, and here it requires high cost photonic components in the central station and medium cost components in the base stations, right? This is the conventional difference between, that is the basic difference between UROF and as well as conventional RF, whereas in working part it is same, but this UROF is mainly focused for PAN network, personal area network, whereas this is mainly focused for cellular system, right? So today what we have seen is, we have seen the fundamentals of RoF technology, and we have seen the complete working of RoF technology, and we have seen the basic difference between UROF and RoF technology. I believe this video will be very useful for you. Thank you, my dear students.